Good afternoon, everyone, and welcome to the latest Big Data London webinar. Today's the first in a new series called Blueprint, and we'll be focusing on observability. There's been lots in the news about observability recently, lots of hype, and obviously Werner Vogels, CTO of AWS, has recently stated that observability is everything. So I think we've got a lot to get through, and we've got a lot to learn today, so that will be good. I'm Andy Steed, Content Director of Big Data London, and joining me today is Johan from ISTEP. Hello, Johan.
Hello, Andy.
We'll, like every session, it's designed to be interactive, so please send in your questions at any point using the question function, and I'll endeavour to ask as many as I possibly can at the end of the presentation. Really quick housekeeping note. If the video stream gets interrupted for you at any point, it shouldn't, but if it does, just hit refresh on your browser and you'll join us straight away. However, without further ado, I'd like to welcome on our main presenter for the day. Over to you, Johan.
Thank you very much, Andy, and welcome everybody to this bright talk. I'm going to present my presentation and just shut down my camera to save some bandwidth, just to avoid to crash everybody. So bear with me, and we will get started right now. So welcome everybody. Good morning, good afternoon, or even good evening. I'm really happy today to be with you to present this complete guide to observability. My name is Johan Le Chevalier. I am a senior solution engineer working at ISTEP in London. And I am delighted today to present this talk where I am going to firstly address the concept of observability in today's software industry. Secondly, we will go through the concept of what we call deep systems and understand why we need to have an observability solution for them. And from there, we will understand that the conventional ways to approach observability are problematic. They may not fit for purpose. So that in the last part of this presentation, I will present ISTEP and our approach to the concept of observability. So first thing first, ISTEP is a company based out in San Francisco with offices in London. As a startup, we have built an opinionated platform that brings out-of-the-box capabilities for you to have a simple observability for deep system solution. And it brings out-of-the-box several use cases, such as real-time monitoring, regression detections, and service level indicator or performance monitoring. And that is how we address observability for deep system. So what I want for you today to take away from this presentation is to understand what is observability and basically how do your architecture, your software architecture may require an observability solution and why it's important to have an observability solution and what you can benefit from using it. So first thing first, we are going to do a little bit of academic work before starting, basically, by talking about definition. So obviously, and I apologize for that, it's a little bit academic there, but it's just to put the context of what observability is. So it's a term, observability, it's a term that was originally used and introduced as part of the control theory. And it was used, if you think about in the context of factories, chemical distillation plants, and so on, where basically site reliability engineers, they need to understand complex processes that could be appearing in black boxes. And the concept of the observability in the control theory was really to understand from external signals what is happening into a complex system without really having to open the box. So by analyzing the outputs, understanding the inferred process internally that can be running and happening in a black box. So that's the starting point to understand what observability is. But what does that really mean for us as software engineers, and is precisely applied to software engineering. So the definition of observability in the ecosystem of software engineering is basically the capability to navigate from an effect to find the cause of the effect. And it's not the other way around. So let's take an example. You detect a problem, a spike of errors, and based on this spike of errors, you identify a misconfiguration or even a bug in your software. So that's the approach. By the effect to identify the cause. And obviously, if you know the cause, and it's like a bug creating the effect, you would fix it. So it has nothing to do with observability. So observability is really to infer from an external signal what is happening internally. And it's really powerful and helps to understand outside of the system what is happening inside. So practically, observability is going to tell you what is going on in your system, and it's going to help you to identify problems that may happen across your components. And it may be totally trivial for individual systems, but as your software architecture evolves into distributed systems, it can be very complex and difficult to address. So answering this very trivial system, question of what is happening on my system, if it's a distributed system across organizations, across services, or across teams, or even across different places, is very difficult and complex. So to that extent, the market, or if you want, the industry, has decomposed this approach and provided some technical answers to address observability. And it is commonly implemented with three so-called pillars, which are metrics, logs, and traces. They are commonly accepted as the three components that bring all together the observability you require for your system. And indeed, each of them provide a different nature of data, and as a whole, they provide the picture of what is happening. So, for instance, with the metrics, you understand that something is happening or something has gone wrong. You may have an alert triggered because of that. With the logs, you have the description, basically, of what has happened, the details of what has happened. And with the traces, you have the context of what has not worked, what has happened, basically, seeing what was before and seeing what is after, and basically having the picture. So all of those three pillars are great sources of data, but they don't absolutely encompass all of the observability requirements. And the reason why is each of those have a natural flow. And this flow makes an observability solution difficult to fit for purpose when addressing modern software architecture. And we are going to cover that right now. So let's start with the metrics. It's a metric really look like one of those diagram. It's a value displayed over the time. This value, it can be anything. It can be a CPU usage. It can be a temperature. And on those values, each value is associated with a time. So this tag, key value pair, is basically displayed frequently, and we do draw different lines between those different points, and you get metrics upon which you can have alerts if it deviates from a specific expected value, or even have machine learning things detecting behavior and helping you to understand what's going on. However, the metrics have a problem, which is the cardinality, the dimensions that can explain your time series. What I mean by cardinality or tags is basically, like for this example, taken from one of our problem we had on internal system at ISTEP. It represents, let's say, a CPU usage consumption. So we detect that from the curve that something happened after 1 p.m. At this specific day. So we understand there is something wrong. Can we see and detect what is wrong? No, not really. So at this point, we would have to make a group by a tag, another dimension, and this tag could be, for example, a container ID. So by grouping by container IDs, we would see then, for instance, that a specific container went just off-grid and burnt all its CPU resources. So we still, at this point, don't understand what is the problem. We see where the problem may be coming from on a specific tag, specific host, specific container, as an example, and we can then from there carry on the investigation. So as this example illustrates, metrics can be very useful in the way that they can help to visualize that there is a problem, but they may not describe what the problem is. And as your system may evolve into a more complex or distributed system, the number of dimensions, the number of tags you would have to cover would increase dramatically. And basically, it has a cost. And the cost is often hidden in your metrics provider license agreement. And if you try to increase the number of cardinality, the dimension you monitor with the metrics, your license is going to increase as well, making somehow a very expensive solution. So the second approach relates to the logs, and the logs have been here forever, I would say, and they are somehow we have a very firm understanding of what they are. They can you can log, you can write statements in your code and write in your logs meaningful information in a structured or unstructured way, and that can be sent on a centralized place where you can afterwards aggregate, analyze, and get meaningful information from it. However, as you move into a distributed architecture, where potentially your transaction rate is going to stay more or less the same as for your monoliths, but decomposing this monolith into several independent containers or microservices, the number of moving parts, generating logs is going to increase. And if you need to consolidate those logs on a central place, meaning you need to ship those logs from your runtime to a centralized place over the network, the cost of sending the data over the network is going to increase, as the number of events is going to increase by the multiplication of microservices. And likewise, the cost of retention associated to this increased amount of data is going to cost you much more money than the actual increase of revenue that your system is potentially generating. So the approach of logging on distributed architecture, on microservices, for example, is very expensive, and most of the time it is not followed. And last but not least, traces. They usually looks like something similar to what we see on the screen in people's mind. And here it's an example of a screenshot with Zipkin. And there's so many different tracing systems available in the place. But here it's an illustration of the visualization of a distributed trace. So the common elements for those distributed trace is that they share a timeline, and every segment represents an action which is achieved on a distributed component, which can be a container or virtual machine or whatever, so that we can understand the global transaction end to end and see the big picture of the events when they happened, and identify potentially the critical paths in the trace, where you spend more time, where you consume time, or where you have errors, and have the previous and the what happened before and what is happening after those problems or those bottlenecks potentially. So they really bring the understanding of the context of the event. However, due to the nature of the trace, you may be tempted to have a sampling strategy to maybe adjust on the costs or adjust on the performance, and in a way to manage the amount of events you are collecting, or to adjust potentially impacts on the performance by this tracing system, or just optimize the cost of storage them. And then being actually implementing head sampling at the application level, basically deciding to randomly drop events or keep others, or making tail sampling based on a centralized system, which can be very complex. But in both solutions, by sampling, you potentially are going to miss outliers and introduce gaps into your end-to-end transactions, which could be the problem you're trying to observe and identify. So in a nutshell, basically, logs, metrics, and distributed traces, they all provide important information, data, but they come with a fatal flaw. Logs, they don't scale gracefully in terms of TCO as your level of traffic scales. Metrics, they are not immune to cardinality, and traces, they are subject to sampling. When they're subject to sampling, you lose basically context and meaning. So what has changed and how did we get there, basically? And one of the main reasons is scale. And when we speak of scale, it's not about the scale you had when you had more of something similar, like you had more water in a pond and it becomes a lake or even an ocean. So that scale way of things is scaling wide of the same thing. And when you scale of the same thing, it's very easy and, let's say, trivial to address from a computing point of view with techniques like MapReduce. But when we speak of scale, and when we think of scale, it's more like scaling from a very small village into a much more complex city, where basically the structure is changing, and it's going to be much more different from a very simple two-dimension, I would say, village, where in a city you have much more ways of interaction and level of depth. And if you want to go from one place to the other in a big city, you may not be able to do that without any tools such as using an app to order a Uber or a Lyft, or even using Google Drive to help you to go from place A to place B. While on a small village, it doesn't really matter. You just need to cross the street to meet someone. So systems are scaling deeper, and to be able to use them, to monitor them, you need new tools, new ways of monitoring them, new ways of observing them. So a deep system, regardless of, can be already in place within your environment, regardless of your languages used. It can be iOS, it can be Android, Java, Node.js, or whatever, regardless of where your services are running, on-prem, in the cloud, private or public, or a mix of all of that, regardless if it's microservices, serverless functions, or virtual machine or bare metal servers, you may have different components making your solution, and they interact with each other, and they may not be isolated anymore. So you may have different layers, and some of them may be totally out of your control. Like, for example, if you're using third-party APIs outside of your team or your company, as an example. And that said, even if you are in charge, you or your team or your company, you are in charge of a specific part of this implementation, which means you are getting some ingress from other components, and you're your services or your components, they are getting some egress towards other services or components, even if you're only in charge of one part of this chain, the impact you may have with your service may be much wider, and you may not be able to control that. However, you may be responsible for all of them. So that is what we call the stress induced by the depth of your system, which is the difference between what you can control by fixing bugs, updating, and developing features, and what you are responsible of in the big chain, with the wider view between the ingress and egress element getting to your system, and which you don't control basically. So that's why using traditional tools such as dashboard metrics, telling you that something is getting wrong, but not really understanding what is wrong, because it's became the gauge became red, and you understand that there's a problem somewhere on one container as an example, but you still don't know what is the real cause of the issue. Or by using your traditional logs approach, where you need to consolidate all your logs and parse them, and potentially have to correlate a lot of different sources in those logs, or using traces, individual traces, to dig through and to have a view of independent and individual elements, is not going to help you. And because every view is partial, sometimes it's it's sampled, so it's not complete, and it's going to fail to provide an observability solution, and the results and the consequences may be in different ways, affecting you or your company. So you may spend more time on call to figure out the cause of an issue and to solve it. So it may impact, obviously, the revenue, it may impact the brand image, but as well, because you are not confident in deploying new features in your services that you control, because you don't really know if it's going to break down something further downstream or have some weird interaction with upstream components, you just slow down your speed of innovation, and it may decrease your development velocity, and as well on your team and on the effect of your developers, develop apathy and fatigue. People, they are tired, they are not happy, they move away from the company, or maybe as well induce some sort of tribal knowledge reliance, where basically everybody rely on more or less on the same people, those who have been here for a while and knowing everything, and at some point making those people the single point of knowledge, and it may be difficult to get their time when necessary to address problems. So that's the possible ways of witnessing that you have difficulties to manage your deep system, and to be able to move forward, to be able to solve this problem, you need a platform, you need a product that brings you observability. Observability not only for your service and your dependencies, but for the team service and dependencies, and the other team service and dependencies. So a platform that brings observability cross-wide teams and services, not only for you, but for the others, so that you can identify bottlenecks, you can identify root cause analysis very quickly, you can identify regressions when you deploy new components and new features, and be free to innovate quicker and stay ahead on your market. So at ISTEP, our philosophy is that the right observability solution need to be to provide an easy way to understand your highly distributed environment in real time, as it changes all the time and morphs daily, to be able to understand canary deployment and CI/CD pipelines, establishing constant changes as a standard, but also to easily pinpoint performance issues, because it's critical to have visibility into service relationships, including upstream and downstream dependencies, whether or not it's for a specific customer or related to a single host, as an example. And last but not least, it's also important for this platform to bring to the developers the capability and the confidence to ship new features where basically they don't need to worry about the consequences of innovating. They just need to focus on shipping code and features. And if something goes wrong, the observability system is going to detect it and help you to figure out what is the cause of the problem and to solve it very quickly. So our approach with ISTEP is to bring observability from the context. And the context, as we have seen previously, comes from the distributed traces. So most of the traditional solution providing tracing solution have two problems. Firstly, they generate a massive amount of information, and they certainly depend on aggressive sampling that limits the data collected, but in turn, it stunts the effectiveness of the analysis. And secondly, they may not capture the trace individually and present them in the UI as a long list of clunky search functionality. So ISTEP, on the other hand, is going to analyze 100% of the traces and is going to construct for you meaningful models of your data so that you can easily understand the pattern and the shapes of your data over the time. And this is going to allow you to determine at a higher altitude when and where there are performance issues, and determine whether this issue is your responsibility in your team or someone else's responsibility to solve. And if it's not in your responsibility, you can share your investigation over Slack or by email, and so that the other people can carry on the investigation and dig into the data, explore down to the database call, as an example, if necessary. So ISTEP really makes it easy to pinpoint issues that will normally be very hard to find. But also, ISTEP, as an opinionated platform, is going to bring what we call automatic deployment regression detection, which is going to provide immediate insights for developers when they publish new services. And as we all know, being able to release new features very quickly may be challenging if you don't have any way to identify any potential regressions. So with our approach, by using tags, we are going to automatically identify deployment by version number and charting latency and error rates. And you can then easily investigate regressions and compare versions to see performance differences in operation, tags, and distributed traces, so that you can investigate them all the way down to the log line and the error messages, and view detailed interoperational diagrams to contextualize the affected blast radius of the issue. And all of that also ISTEP also provide a real-time capability for letting your support engineer or your SREs to effectively have access to 100% of data when they are in an incident investigation, so that they can get to the root cause and, of the problem very quickly and reduce the mean time to resolve an issue. And by exploring and slicing and dicing in all your data by service, operation, or tags. And having group by capabilities to ease your analysis, having correlation analysis capabilities provided into your analysis, and even a dynamic service diagram to help you to identify and visualize the hotspots of the performance issues, so that they can go very quickly into the problem. And all of that is based on a no vendor locking approach by using open source standards. So instrumentation is based on open tracing or open telemetry. ISTEP tracers are open source as well. And we strongly believe in open source standards, so that you are not locked into with a specific vendor. You have your environment instrumented, and with open source standards, you can use it that way and provide meaningful information to ISTEP, and ISTEP provides out-of-the-box those very meaningful use cases, and as well provide you the capability to monitor your serviceable indicator and operation, and have alerts triggered if errors, latency, or operation rate deviate from the expected behavior. And those alerts would be sent with context of traces, so that as soon as your team gets the alert, they straight away get examples of what happened and start to work on it straight away, instead of wasting huge amount of time into filtering the signal out of the noise of false alerts. So that's, in a nutshell, what observability with context means for ISTEP, and what ISTEP platform provides in terms of features and capabilities out of the box. So you certainly ask and wonder how it's possible to achieve that. And it's really based on a very innovative architecture. There is no magic, it's just data. And what really makes ISTEP different is that we are able to ingest all the monitoring data and the metrics, the logs, the tags, and the trace, even from our largest customers who are handling millions of requests every second. So it's very innovative, and at the beginning of the architecture are your applications. It might be hundreds of microservices, or maybe just 10. It can be legacy monolith applications and a mix of all of that, or it can be web or mobile clients. They all send data to a collection layer, so-called satellites. The satellites, basically, they are designed to run within your environment, and they are meant to scale horizontally. If you want, they are stateless appliances. They can be deployed as containers, virtual machine, or bare metal servers, but really meant to scale up horizontally. As the monitoring information increase, you can add new satellites behind the load balancer, and you can tear down the satellites as you have less traffic. So they are going to keep the monitoring information into memory to enable real-time queries capabilities. And we are going to have 100% of the monitoring data captured by the satellites. And based on the satellites and understanding of what's happening from the SAS, we are going to, after a period of time, to make some element of filtering, aggregation on the data on the satellites, and push back to the SAS meaningful informations. So there will be what we call a dynamic tail sampling, if you want to call it like this way, based on the global view of what is happening on the satellites. And we are going to collect and to keep and preserve the outliers and get all the meaningful information pushed back to the SAS. So this approach enables the satellites to be deployed as close as possible to your applications, so that there is no overhead over the network to send the monitoring data, and you are able to collect 100% of the monitoring data between your application and the satellites, and so that we can detect any outlier. And the SAS is going to provide all the use cases, the trace assembly, so that you can have access in real time to all the monitoring data on the satellites, and the SAS is going to build the analytics and the trace assembly, the correlations, the monitoring for you, and detecting the regressions. So there is no specific effort with the SAS to produce. It just brings an opinionated platform out of the box use cases, as long as your applications are instrumented and provide monitoring data with open tracing, open telemetry, or even with open source other tracing tools such as Jaeger or Zipkin, which can be ingested natively into ISTEP. So we obviously have a lot of success, and our customers speak better than us from the platform and how it helps them to solve problems. And some of them have been heard on Twitter. I may just mention a few of them, like this one. I'm so impressed with ISTEP finding the bottleneck of any of my latency issue was easy. after a couple of hours of debugging, I ended up improving my application performance by 70%. And yes, wow, 70%. So it's how ISTEP can be used not only as an observability platform to detect problems, but as well for developers to improve their performance application, because they bring the context of distributed traces with an unsampled approach, so that you can very quickly identify the slow patterns on your application. And from the context provided by the instrumentation, you can figure out what could be the problem and how the critical path is affected by those circumstances, so that you can improve it and increase the performance of the application very quickly. And again, based on a tool that is simple to use, because it's opinionated, you don't need to spend weeks of training on the tool. It's available very quickly for the developers, and they can really apprehend it and use it simply. Another good example we have, I'm just going to just read two of them. Just the other day, ISTEP automatically surfaced a problem for us. The correlation engine basically said, hey, this string here is normally like this, but right now it's suddenly like this. And the responding engineer estimates it took 1/10 of the time it would have been used to detect that problem. So ISTEP being able to bubble up the difference, to surface an anomaly, and helping the engineers to solve that. And potentially it's something that would have happened after a deployment of a new feature. So really powerful tool and used in several ways. So as for our customers, let's speak of, for example, of Twilio, where ISTEP basically helped to improve by 92% the time to resolve problems. The problem at Twilio was that they had some significant number of different microservices, and by the number of microservices was getting even more complex to understand when something is going wrong and the impact of the problem. So by continuously analyzing the transaction and the performance data generating by those core services, they wanted to have a solution that would not only not create any overhead, but still bring this observability and providing a macro view of the system and a micro view of the services. And ISTEP was able to achieve that and provide a reduction of the average root cause analysis investigation and by a factor of 92. So that was directly translated for them in terms of business by saving 20 hours every week for the team into troubleshooting, which obviously has an impact on the team. They can spend time to develop new features, which is going to have an impact on the business of the company, because they will be able to provide new features and new functions and innovate on their market. Another great example is under Armour, where basically the developers were fearing to take the on-call because they were lacking the correct tools to understand problems. So when they deployed ISTEP, they straight away had the capability to, from the visibility, the observability provided by the observability platform, to enhance their automated decision. And ISTEP was only showing the traces, not only the traces, but as well the context behind what was causing the issue. So it was really changing the attitude and the approach and the relationship between the engineer and the system. So they were not afraid anymore in lacking context when they were on call, and they were able to find answers in a very quicker way, so that they can solve issues and in a more efficient way. So that's how ISTEP, in a nutshell, is able to help improve performance, reduce mean time to resolve problems by shortening the root cause analysis, basically, and helping developers to develop better software, where they can ship more frequently new features and without fearing being the source of problems they cannot address, basically. And by using those features of the regression detection, and all of that based on a very innovative architecture, hybrid, with satellites accessing and collecting 100% of the monitoring data, pushing back to the SaaS dynamic tail sampled meaningful data, where the SaaS provides out-of-the-box features for this opinionated platform. So that's, in a sense, what is observability for deep system, and how ISTEP can help you to provide observability for your deep system. ISTEP welcome you to test our platform with real data. So you can log in on istep.com/sandbox and have access to a running environment where you can test and follow some examples on how to troubleshoot some problems, how to follow a regression when you deploy a new version of a service, as an example, and see in motion what ISTEP can do for you, and potentially help you to understand the capability of the platform and help you to solve your problems. So, having that said, I've been speaking a lot, and it's time for me to stay quiet and take your questions. So I'm going to pause there, and we will come back to the Q&A session, basically.
Thanks, Johan. Yeah. I just wanted to say quickly that anyone who wants to see any of what's been on screen again, this session will be available on demand almost as soon as this one is finished. So if there's anything you want to rewind or have a look at again, it's very easy to do so on the on-demand feature. Also, the sandbox feature within ISTEP, it's a really good little tool that you should check out, is actually on the attachments that you can see on the bottom left-hand side of your screen there as well, so you can link straight to it should you wish to afterwards. In there as well, we've got a link to some of the upcoming webinars and some other great resources from ISTEP. So I'm just going to kick off some questions with you, Johan. The first one is what's the difference between APM, application performance management, and observability? So I think people are comfortable with what the APM vendors are and what they do, but what's the difference between that and observability?
And basically it addresses two different sort of problems. An APM is really focusing on the performance side of your application. Sometimes it manages more or less well to address distributed application performance, and somehow it's mostly used for monoliths or local applications and having difficulties to manage distributed applications. But observability, it's really encompassing and getting over the application performance only approach. It's really taking you to the journey of having visibility of what happens cross services, cross function, cross teams, and being able to understand not only instantaneous data, performance data, contextual data, but as well having an holistic view over the time, and being able to detect, as an example, regressions, being able to detect behavior of your service over the time. And that's really a big difference with what we call APM, that only brings the performance view of things, but not necessarily a holistic view of the performance plus the behavior plus the regressions and the over the time on your system, regardless of the service boundaries.
Cool, excellent, thank you. Yeah, we've got a couple of similar questions here, so I'll try and merge them together. Again, how is it differing from traditional monitoring tools? So, sort of, I guess more systems monitoring tools, and is observability an umbrella term for kind of AI ops, system management, and ITSM kind of mushed together? I'll rephrase that question. I'll say, why is observability more than just AI ops, system management, and it's smushed together? What more can it do, and what more can people expect from it?
So, well, it's a very good question. So the observability is really the approach of bringing you this holistic view of what happens, regardless of the context where it is happening. So it can be anywhere. It can start on a mobile device and complete into a cloud provider backend service. The observability is going to help you to have the holistic view of what happened at every steps of the transactions between your different application components. And the observability platform is going to be here to help you identify problems. And it's going to be here to help you to identify regressions, because you definitely need a solution to help you to push new version of software and detect when they have an impact and they have regressions, as well as on not monitoring the performance on a daily basis and see the service level indicator for your different components. So it's really a very mix of all those things that are addressed by observability, and having traditional tools relying on trace metrics and logs fall into traditional flows. And that's where there is a necessity to have a new approach, a fresh approach, where you must not only take 100% of the monitoring events, but you need to have a backend environment which is going to provide you this capability to interact in real time with your system, to provide in real time answers to question and correlations, and to be every case will be different, and that's going to be one of the main issue with AI and machine learning tools. They may fail to provide meaningful insight due to the rapid change and morphs of the context, basically.
Perfect, thank you. And just a couple more questions for you before we wrap up. So we've had some specific integration questions. I think it's probably best we get back to you offline on those ones. But yeah, we will definitely answer those for you. But one is, are there any open source components of ISTEP?
Yes. So ISTEP is co-founder and developer of the open source open tracing, and is co-contributing as well to OpenTelemetry, which are open source standards to provide observability on distributed systems. ISTEP components, such as the tracers, are as well open source and available on GitHub. So the part of the instrumentation and the tracers are all open source components. And it is fundamental for the public to understand that having instrumented your applications with open source standards is a key for you to be successful, because you are not relying on a specific vendor to provide your observability events, which are data. And where there is a need for competition is on the solution that use those data to bring meaningful use cases without making any concession on the accuracy and on the fidelity of the data you're analyzing. So that's really our approach, is to push open source standards for adopting instrumentation with open tracing or open telemetry. And based on those standards and your application being instrumented with them, you are not locked in with a specific vendor, and you can choose the best on the place. and we hope you will determine that ISTEP is the best that fit your needs.
Perfect. And so, yeah, so just one final question from me, Johan, if that's okay.
Sure.
Obviously, the examples you gave were really good examples, and I imagine you gave them, Twilio and Under Armour and stuff. I imagine you highlighted them because they are big companies and, big famous companies that we've heard of. But I mean, is ISTEP also for your smaller guy, your smaller player? Are they going to get use out of it, just in case there's anybody listening?
Absolutely, yes. We have designed the product to scale with your needs. So this approach is also reflected in the way we address our customers. So there are several customers of us. They start small and they expand their instrumentation, their monitoring, and their observability journey, and they are happy to work with ISTEP. ISTEP takes a lot of care to its customers. Every customer of ISTEP has a pair in the customer success team, really here to help them to adopt and use the platform and being successful on their journey to observability, regardless of their size. So you can start small in a small team with ISTEP, and get value straight away with ISTEP, and step by step expanding that to more core feature of your product or your software, and scaling your adoption with ISTEP. And it's the platform and the team and the company is really designed to help you on this journey, because we really believe that observability is not a one-off. It's a process that that is improved step by step. So you start small and then you increase the visibility you want to get into your different services and components. And it is exactly what happened to our biggest customers today. They started small, and step by step they have expanded their footprint, and our platform has helped them to expand, and has been and it is designed to help people to expand at production level.
Perfect. Well, that seems like a good place to end it, Johan, if that's okay. So
Fantastic.
I'd like to take the opportunity to say a big thank you to Johan, our presenter today. Looking forward to future episodes within the Blueprint series. We'll be taking on some other subjects in the principles of data architecture and software architecture. So from all of us here, goodbye, and we'll see you at the next one. Thank you very much. Bye-bye.
Thank you very much. Bye-bye.